Hello. My name is Philip Massey, and this is my 352 project on the programming language NIM. Overview for this presentation. I will be covering the history and origins of NIM, why it was created, what is it typically used for, what are the pros and cons of NIM. I'll walk through a code example, explain it, and my personal reflections on the language. All right, firstly, what is NIM? NIM is a compiled language that also supports object-oriented programming, though object-oriented programming is not its main focus. It compiles to C, C++, or JavaScript, producing fast and efficient executables, while it allows object-oriented programming with features like objects, inheritance, and method. NIM is a multi-paradigm language, letting you mix procedural, functional, and object-oriented programming styles as needed. History of NIM. NIM was influenced by specific characteristics from multiple language and functions programs, all that. Taking from Module 3, Object Pascal, ADA, C++, Python, Lisp, Operon, C Sharp, and Paracel, just incorporating different aspects from different languages coming together as NIM. History and origins of NIM, created originally by Andreas Rumpf. In 2005, he began developing NIM as a personal project to create a language that combined the performance of C with the expressive power and elegance of Python, claiming it to combine the best parts of ADA typing system, Python flexibility, and powerful Lisp macro system. It was originally called Nimrod. The language was renamed to NIM in 2014 to simplify its branding and avoid negative connotations with the word Nimrod. 2008 was the first public release of Nimrod, which is now known NIM. 2011, it gained traction with a small but growing community. 2014, that's when the rename to NIM began and moving towards a more stable release. 2015, the 1.0 pre-released version was released. In September of 2019, the official 1.0 release was made, marking the language as production ready. And ongoing development is active with version 2.0 released in 2023, featuring an improved type inference, performance, and tooling. Why was NIM created? NIM was created to be a language that combines, again, the performance of C with the expressiveness and readability of Python, addressing several limitations the creator, Andreas Rumpf, saw in existing languages, offering, again, the performance like C, the clean and expressive syntax Python offers, similar to that, powerful metaprogramming, memory safety with manual control, and multi-backend compilation. What is NIM typically used for? NIM is a general multi-purpose language. A general purpose language, but it's especially well suited for tasks that require performance, safety, and cross-platform support. Typical uses are like system programming, command line tools and utilities, web development, game development, embedded and IoT programming, data processing and scripting, and metaprogramming. NIM is a language that offers many pros and cons. It's a fast language that compiles to C or C+, with performance, again, close to those languages, with a clean, easy, beginner-friendly syntax, similar to Python. At the same time, it has powerful features like macros and compile time code execution, which will let you write flexible and efficient programs without slowing things down, mainly. NIM gives you control over memory using garbage collection by default, but also letting you manage it manually if needed. It can compile to JavaScript and WebAssembly as well, working easy with C code, and creates a single file program that are simple to share and run. So overall, the pros include high performance, clean and readable syntax, powerful metaprogramming, flexible memory management, cross-platform and multi-backend compilation, seamless C interoperability, as well as static binary distribution. Um, though having all those pros, it does have some cons or negative aspects of it. NIM is relatively new. With that, it has a relatively small ecosystem with like fewer libraries and community resources compared to more established languages. Tooling like IDE support and debuggers is still developing, which can hinder productivity. Documentation is often limited, especially for third-party libraries. Some features remain experimental or subject to change, affecting long-term stability. Heavy use of macros and metaprogramming can sometimes slow down compilation and make debugging more difficulty. So overall, the cons include small ecosystem, maturing tooling, sparse documentation, experimental features, and slower compile times with macros at times. Now I'll show a coding example. Our class 352, we were asked to create a code, a program, the landline that greets you in our respective languages. This NIM program is a command line tool that prints a greeting like "Hello Alice" multiple times depending on the user's input. It starts by importing two modules, OS, which allows a program to read command line arguments, and strudels, which provides tools for working with strings like converting a string to an integer using parseInt, stuff like that. The program calls command line params right there to get the list of arguments passed by the user. These arguments are stored in the variable args. Next, it checks if the user provided at least one argument. If not, it prints a message telling the user how to use the system properly. Right there. This means the program expects a name and optionally a number. If a name is provided, the program saves it as the name variable. Then it checks if a second argument, the number, was provided. If it was, the program converts that string into an integer using parseInt and saves it as the count variable. If not, it defaults the count to 1, the count variable to 1. Finally, the program enters a for loop that runs from 1 to count. In each loop iteration, it prints the message hello, name, whatever name input was provided. Personal reflection. Though relatively young, I feel NIM has a lot of upside and potential with a lot to offer. A somewhat simple syntax combined with high-level performance is great for both low-level programming and higher-level tasks, making it a versatile choice. What really stands out about NIM is its metaprogramming abilities, which allow you to write code that can generate other code at compile time, help you keep things efficient and clean. NIM also lets you compile your code to different platforms like C, JavaScript, and WebAssembly, so it's useful for a wide variety of projects. That said, NIM is still a relatively young language, and there are some downsides. Its ecosystem isn't as large as other languages like Python or Rust, so you might struggle to find the libraries or tools you need. The community is still, however, growing, and things like IDE support and debugging are not as polished as in more established languages. However, I don't mind these challenges. NIM offers a lot of flexibility and performance for projects where you need efficiency without sacrificing readability. Overall, NIM, I believe, is a cool language with a lot of potential. It's great for projects where you need speed and control. While it's not perfect yet, it's definitely worth checking out, and if you like experimenting with new languages.